That's my second tutorial on FVD++, and today I will be talking about force sections and first drops. Actually, I want to apologize because on my first tutorial I unfortunately deactivated the mouse cursor, so you probably didn't really get well the understanding of how the program really works. Well, I hope it's fair, but I could have been I could have done it better. But anyways, on this one I'm sure that the mouse is activated, so you will be able to see everything that I am doing here. So let's actually start. So let's adjust the friction as always. Let's go to edit and add a straight section here. Let's say 20 meters. And then the lift hill, let's just put so we have reached the top of our lift hill. So now it's the time for me to explain better that thing that I talked about, fixed speed and lit out. Well, at the top of the lift hill you have to have set your final speed. So that's gonna be the actual speed in which you're gonna put on your project there in the simulator. So let's adjust the track radius for about 12 and then a fixed speed of 3 meters per second. That should be great. And then let's deactivate it, delete out. So the main part of the FVD++ is that the force sections provide you make the actual elements of a roller coaster. So the first section, in the first section, we assume that the train is actually rolling, all over the track. I mean, by using the gravity. So at the end of the lift hill, the train will be released and complete the track by just using, potential and kinetic energy. So you just have to add a force section here. Let's just make sure that delete out is deactivated. You can see how the graph changed, because now the graphs are showing how the g-forces are working along throughout the track. This white section here is the section that we just added. Those are three main things that we're going to be using and we're going to be changing according to our needs. So this blue line here is the normal force, the normal that is in the vertical axis acting upon the rider's body. And the right side of the graph you can see here the values of g-forces. Currently we have something between 0.6 and 0.8. If you scroll the mouse, you can you know, see how it changes. You can see it closely, how the forces change. Um, and then we have here the roll, which is represented by this red line, and it's measured on the left side of the graph. And here we have the lateral force. We usually set the lateral force for always 0. So for you to just lock it, you just have to press to activate dynamic right here on your left. And for now, we're gonna also activate the dynamic mode for roll, because we're not gonna change the roll right now. For you to be able to actually see how the g-forces are varying throughout the track, you can just go ahead and click on visualize up here and then normal force, so that you will be able to see on the track, on different points of the track, how the forces are varying. What we're gonna do next, you can see that the g-forces is around, let's say, 0.7, yeah, something like 0.7. Let's say we want to perform more inclined drop. So what do we have to do? If you imagine that as the train goes into the drop, you feel like your body is losing weight. What do we have to do for the train to perform something like this? You're gonna have to decrease the g-force. So here on your left, where it says cubic, on the right side of cubic, you just reduce the g-force. Let's say we want something around 0. For you to be able to see what is the actual value of the g-force at that point, you can look up here where it says y acceleration, because this is the vertical force. And let's just, yeah, okay. So let's just set it, it says here 0.082, so let's just put 82 here. Now we have a 0. It doesn't matter if there's a plus or minus here, because it's just by approximation. The program works by approximation, so you just have to make sure it's 0 if that's what you want. Well, we already have 0, but we do want to increase the size of the drop, the length of the drop, I better say. So here is the value of the g-force, and up here is the length of the track. But the length is in terms of time, which is in seconds, not in meters. You can change, I guess you can change it, but I particularly prefer to use length in terms of type. So let's just increase a bit. Let's just increase a bit for 1.5 seconds. What comes after? So we all know that after the actual drop, there's a positive G section for the train to be able to perform the second part. So that's something like a curve down here going straight to the ground. So we have to increase the g-force in this part. So it has to go from 0 here to something like 3.5. So you just have to add one new segment on your force section by clicking on append. You can see that there's a new force section here, but it's still 0 because we haven't done any changes after the 0 section force. I mean 0 force section. So you just have to increase the g-force by adding something like 0.3.5. That should be fine. But you can still see that it has not reached the ground yet. So you can just go ahead and add a new section. It will automatically adjust for 3 because that's the last value that you have set for this for section. So the program just follows what you have added before. What happens now is you can adjust the length of each subsection of your for section for the ride to be performed smoothly. So let's say we want something a bit smoother, so you can actually increase the size of the subsection where you changed the force from 0 to 3.5, and you can do it by increasing the length here. You can see how it goes up a bit more downwards. Just make sure it doesn't reach the ground, because for example, let's set it for, if you reduce this third section here, you can set the pitch for 0, just for you to, for something around 0, not exactly 0. For you to make sure that it doesn't go into the ground, you can actually visualize it, or you can see the height of that specific point. So it says here in the y-axis that the height of that point is 1.722. That should be fine, right? But let's say you want to, you can see that you can see that the negative g-force section is a bit longer than the positive g-force section. And that's good, I guess, because it's better for the rider to experience a longer negative g section than a positive g section. So let's just, you can see that the negative g section is 1.5 and the positive g section is 1.2. So that's good. But if you do want to perform this change more smoothly, you can reduce the negative section and increase the positive changing section. You can see how that middle part here increases. So that should offer a smoother ride experience for the ride. For you to actually experience your POV, you can just right click on the button of the mouse, and then you can press space, and then you can go forwards or backwards on your ride just by pressing respectively W or and S. So we have here the top of our lift hill, and then we are performing our drop. So that looks a pretty drop. So far we have done something using four sections. That's basically how the four sections work on FVD++. But let's say we do want to perform a curved drop, something that curves either in the bottom of at the bottom of the drop, or a completely curved drop. So let's just left click here on force and delete it. I mean, no, not deleted yet. Let's try a curved drop that starts curving closer to the bottom. So you can deactivate the roll and reduce the length like this, and then you can click on a pen and lock it again. Well, when I do it, I assume that this part here performs a roll from something around here to the bottom of the drop. So I will be able to perform a curved drop at the bottom by either, for example, let's say you want it curved to the left, you can just increase for something around 60 degrees per second. You can see here that it kind of curves as we desired, but you can still see that it's too close to the ground. So what can we do to change the situation? Once again, you can reduce the previous section. So let's say we want to reduce for the track not to like hit the ground, so you can just reduce here, and then actually no, I made a mistake, sorry. You can actually reduce the, because that's something else, so you can actually reduce the negative g-force section for something around 1.2, and then you can kind of curve it again. If you want to increase the bottom of the drop, you can add a bit more of a length on the third normal section. You can see how it curves a bit. So the more you increase the size of the roll section, the more rolled it's gonna be. Once again, we are not actually changing the roll, but the roll speed. That's why it continues changing as you increase the length of your roll section. Well, you can see that we can still add something a bit here in the negative normal section. So let's say we want to do this. Just in general, the larger the section, the smoother the ride experience in that specific part. Just in general, it has those specific cases in which that doesn't work, but those are more complex that I will be talking about later on. There's a little thing that I want to show you guys in terms of smoothness for the roll section. FVD, I guess my particular experience with FVD kind of makes me say that everything is pretty much automatically smooth, but you can do it even smoother. So you have this graph here. How can we do that smoother? You can reduce the tension here on your left and see how the graph kind of curves differently. When the graph does this, you can see that the curves, the way that the curve behaves is different, because it doesn't curve immediately. It starts from down to up, and the more you reduce tension, the thinner the graph is gonna be. But let's not reduce the tension that much, because the ride experience can be a bit rough if you reduce too much. So I usually put something between -1 or -1.5. Let's just let it for -1. And let's perform this part of the track just to see if it works well and smooth. Yeah, it's fairly smooth, I guess. Once again, depending on the height of your lift hill, you can do it a bit smoother by increasing the length of one of the sections. One important thing that you guys have to notice on FVD is here, this whole line here shows all the parameters that are being changed on your track. So we have the X, Y, and Z axis. Generally, when you are designing a specific part of the track, those three values are always gonna show the endpoint of that part. So those coordinates represent this point here, as well as the roll. So this roll value here represents the roll at this endpoint right there. The pitch, as well as the pitch and the yaw and the speed. So at the bottom of this drop, nothing changed about the acceleration. It's still approximately 3.5 Gs. The only thing that we have changed is the roll for this part, but we actually maintained the value of the G-force. And of course the X acceleration, which is the lateral force, is nearly zero because we haven't added anything for the green line, which is the lateral force. So let's say that now I want to do a completely curved drop. So we can just go ahead and delete it and redo everything again. What I mean by curved drop is something like the SLCs, like the Vacom SLCs drops. They are usually entirely curved, or the B&M inverted coasters, or something like the drop of Kamba, something like that, just for you guys to be aware of what I'm talking about. Once again, let's add a force section. Let's log the literal force, and for now let's log the roll. So the difference here for this curved section is that we will not be able to add up, like to decrease the G-force so much, because otherwise the drop will not perform well as we desire. So let's reduce for something a bit like -3, and then we're gonna add a new section and put something around 3.5 here. I'm looking at this value here, not here. Sorry, because of course if I reduce to -0.3, I have to increase for 3.1 for this to be equivalent to 3.5 at the bottom. And then we can just increase here and add a new section. let's not add this section right now. Let's increase the negative G4 section. So we were able to curve the bottom of the drop by adding the segment closer to the bottom. But now what I want to do is curve the entire drop. So what we're gonna do, we need to reduce as much as possible the roll segment, and then we can, like this, as I just did, and then you want to add a completely new section, row section, and then you're gonna go ahead and lock it. Now we can basically start curving the drop like this. As you can see, it's still not close to the curved drops that I was talking about before. So what you can do to solve this problem, you can go ahead and go back to curved, and then you can reduce the total angle, which ends around here. So by reducing the total angle like this, you will be able to perform a better curved drop. And then of course you can now actually add the last section of your drop. If you notice that it curves more than you want, you can either reduce the value like this, but it seems like it doesn't work well. So let's just put 74 as it was. Yeah, 75 is good. Or you can go ahead and unlock the roll section and reduce the size of the roll like this, and add a new row section. But for you to do that, of course, you have to increase one section like this, and then reduce the third section of your normal force like this. For the curved drop to perform smoothly, once again, let's reduce the tension. I think it works for this case as well. Let's reduce for something around minus 1.2, and then we can increase here a bit more, always looking after the Y value for you, just to make sure that it doesn't go into the ground. And here we have a completely curved drop. Depending on what you really want, you can perform something that goes from here and curves entirely until the next part here, like kind of doing a 180 degrees curve. Or you can just let it like this, something around 90 degrees. And let's see how it works for the POV. It seems pretty well. Let's do it once again. But there's something that I've noticed at the very beginning of the drop. I think it could have been smoother because it kind of rolls too rough. So what you can actually do to perform it better, to improve the performance of your drop, you can go ahead and select the roll section of your track and increase the center and see how the graph changes. You see that it's no longer a symmetric curve like a normal curve. It kind of bends a bit to the right. And of course, if you reduce the center, it bends a bit to the left. By increasing the center of the roll, you can understand from it that the roll is going to start a bit later. Like the top roll value here is going to be a bit later. So that means that the left side of the curve is smoother than the right side of the curve, which is the end of the curve. So that suggests that the curve begins smoothly. And let's see how it goes. It seems a bit better, I guess. So I think for today that's it. I hope you guys have enjoyed my video. I hope that has been helpful. And for the next video, I'll be talking about a bit more complex stuff. And thanks for watching, and have a great day.